What we want to do is we want to write the function for the computer's value. And in the problem it says the value of a $3,000 computer decreases about 30% each year. And the problems that we did, the function looked like this: f of x equals the initial amount times 1 plus or minus r to the x power. And so 1 plus r is a growth function and 1 minus r is a decay function. So when we write the function for the computer's value, it's going to be f of x equals 3,000 1 minus, and then you have to remember we have to put this percent in decimal form, 0.3 to the x power. And then we can simplify this, and it would be f of x equals 3,000 0.7 to the x. So when we look at this, it says, does the function represent growth or decay? Because this number is 0.7, it's decay. And then it says predict the value in 4 years. So now we use the function that we came up with, f of 4 equals 3,000 0.7 to the 4th power. And so we punch this into our calculators, and when we put it into the calculator, we get that this is going to be $720.20. And that's your answer. We want to remember that our exponential form is b to the x equals a. And then the logarithmic form is going to be log base b of a equals x. This value out here is always going to be the exponent. And if you can remember this, it can help you when you're converting from log form to exponential form and from exponential form to log form. So in these problems, we want to convert 4 to the 3rd equals 64. So it's going to be log base 4 of 64 equals the exponent, which is 3. For b, it's going to be log base 6 of 1 equals 0. And the last one is the same thing, log base 3 of 1 over 27 equals negative 3. We want to remember our conversion of exponential to logarithmic and logarithmic to exponential. And in this problem, we want to convert from logarithmic form to exponential form. So we have 6 to the 2nd power equals 1 over 36. For b, we have y to the 1st power equals 8. And for c, we have 2 to the 5th power equals 32. What we want to do is we want to evaluate these logarithmic expressions, and we can do this without the calculator. So if we take 5 to the x power equals 125. So basically this is equaling some value. So 5 to the x equals 125. And so we need to make these bases the same. So this is 5 to the x equals 125 is the same thing as 5 cubed. So the bases are the same. So because the bases are the same, we know x has to equal 3 for this to be a correct statement. The same thing here, we have this equals x. So we say 1/3 to the x power equals 27. Now we can rewrite this as 3 to the negative 1 x equals 3 to the 3rd. And so our bases are the same. So if our bases are the same, then negative x has to equal 3. So x has to equal negative 3. This equals x. So 36 to the x power equals 6. So now, how can we convert this? Well, we know that this can be rewritten as 6 squared to the x power equals 6. Our bases are the same, and remember, what's the exponent up here? It's 1. So we can set these equal to each other, and that's going to be 2x equals to 1. And so x has to equal 1 divided by 2. Log 1000 is log base 10 of 1000. So again, we say this equals x. So 10 to some power equals 1000. We want to get our bases the same. So 10 to the x equals 10 to the 3rd. So for this to be equal, x has to equal 3. And then our last one is this equals x. So then we have 15 to the x power equals 225. We can write these using the same base, so we get 15x equals 15 squared. So the bases are the same, so x has to equal 2. And there's your answer. What we want to do is we want to graph this function, so in order to graph it, we need to list a table of values. They've given us our x values, so we'll start with negative 2. So 2 to the negative 2 power is equal to 1 over 4. Then we have the negative 1 power. So 2 to the negative 1 power equals 1 over 2. Then 2 to the 0 power is 1. And then we're using x as 1, so 2 to the first power is 2. And then we're using 2, and 2 to the second power is 4. So now what we want to do is we want to graph these values. So we have negative 2, 1/4, negative 1, 1/2, 0, 1, and then 1, 2, and then 2, 4. And so there we have our function y equals 2 to the x. Now the next thing they tell us to do is they tell us to find the inverse of the function. Well, we know if we have y equals 2 to the x, we can switch the x and the y, so we get x equals 2 to the y value. So now we're in exponential form, so we switch it to logarithmic form, and logarithmic form looks like log base 2 of x equals y. So this is our inverse. Now we want to graph the inverse, So to graph the inverse, we don't have to do any new work because we have our table of values, and the inverse is just switching our y and x values. So we get 1 to the 4th, negative 2, 1/2, negative 1, 1, 0, and 2, 1, and 4, 2. So now we graph these values. So 1/4, negative 2, right about here. And then 1/2, negative 1 is right about here. 1, 0 is here. 2, 1 is here. And the last one, 4, 2 is right about there. Now what we want to do is we want to graph. And we know that the equation of this line is going to be y equals log base 2 of x. Alright, so now we can also put in our y equals x. We know we have a line that goes through here. It's not an actual line, but we know that our two functions are reflected over the y equals x. So it's always a nice idea to show it. And the last thing that we need to do in this problem is we need to show the domain and range. And the domain of our original function is the black graph is our original function. So as we go to the right, what's happening with our x values, they're getting bigger and bigger. As we go to the left, our values are getting smaller and smaller, and there's no excluded value. So it's negative infinity, positive infinity. The range is, as we go up, our y values continue to go up, and there's no values that we're going to exclude. But then as we go down, notice that we're getting, as we go down, our values get closer and closer to 0, but they're never going to be 0, and it's not going to go past. So our range is everything above 0. And that's what we put down. Now, when we look at our inverse is going to be the opposite of this. But just to look at the graph, the domain of values, as we go to the right, they keep getting bigger and bigger. But then notice as we go to the left, what happens to our x values? They get closer and closer to 0. So our domain is going to be 0 and positive infinity. And our range, as we move up, our range keeps getting bigger and bigger, and as we go down, our range keeps getting smaller and smaller, and there's no values that y won't be. So we say it's negative infinity